Today we're going to be talking about inverse variation. Inverse variation is written as y equals a over x, where a is that constant of variation that we talked about with direct variation. We also have that with inverse variation. Now, something to note with inverse variation is that if we want to find that constant, all we have to do is multiply the x and y values. Whereas with direct variation, to find that constant, we had to divide them. So this can get a little bit confusing because inverse variation, the general equation is y equals a over x, but to find the constant of variation, you multiply x and y. Whereas direct variation, that equation was y equals a times x, and to find the constant, you divided x and y. And then in word problems, we see the word inversely. That's how you will know to use this formula. So example number 1 is asking us to determine whether these are direct variation, inverse variation, or neither. So we need to get y by itself. So if we add 3x to both sides, we get y equals 3x. So that is a is 3. So that means this is direct variation. Letter B, we need to get y by itself, so we multiply both sides by y. You get y times x equals 3. Then divide both sides by x, you get y equals 3 over x. So we have a number divided by x. So that means this is inverse variation. Now, letter C, what we have here, once we get y by itself, is y equals negative x plus 5. Well, we have that plus 5 sitting out there, so this is neither. Letter D is asking us from a table to figure it out. So what you have to do is divide your y over x to see if they get the same value for all of them. And if you do, that means that is direct variation from the other day. Or if you're going to test for inverse variation, you would multiply x and y. So 21 over 4 is 5.25. And 14 over 6, well, 14 over 6, we want to see if that is equal to, we want to see if that is equal to 5.25, but it's equal to 2.33. So it's not direct variation. So now let's check for inverse. 40 times 21 is 84. 6 times 14 is 84. 8 times 10.5 is 84. 8.4 times 10 is 84. And 12 times 7 is 84. So since all of these are equal to 84, or the same number, this is inverse variation. If just even one of those was not the same, then we could not say that this was inverse variation. So down here, I want you to try all of these to see if it's direct, inverse, or neither. So pause the video, try them all, and once you're done, unpause it to see what you get. All right, here are the answers. So like I said, you needed to get y by itself in all of them. So for letter E, you get y by itself. I get y equals negative 2x. So that means that it's a direct variation. Letter F, it was already in y equals a over x, so that's inverse variation. Now letter G, once I started manipulating that, I got y equals x over 5. Remember, inverse variation is a over x. So this is not an inverse variation one. So what I did is rewrite dividing by 5 as multiplying by 1/5. So now it's more obvious that this is direct variation because your a value is 1/5. Then for letter H, I multiplied all the x's and y's and got the same number, which was 9. which means that this was an inverse variation one. So down here, I want to do this problem. The variables x and y vary inversely, and y is 15 when x is 3. Write an equation that relates x and y, then find y when x is equal to negative 10. Since we know this varies inversely, to get our a value, we can do 15, a equals 15 times 1/3, 15 over 3, which is 5. So now our equation is going to be y equals 5 over x, and it's asking us now to plug in negative 10. So y equals 5 over negative 10, which is equal to negative 1/2. Right, on the next page, so the general equation y equals a over x for inverse variation can be written as a equals x times y. We talked about this a little bit, and this tells you that the set of data pairs x comma y shows inverse variation if the products, which means multiply, are constant or approximately constant. So let's look at example number 3 here. So moving cartons are manufactured in a variety of sizes and shapes to accommodate the variety of objects that need to be packed. The table compares the area A of the bottom of the rectangular carton in square inches with the height h of 4 available cartons that have the same volume. So all of these things have the same volume, but the height and the area of the base is going to be different. This is an equation relating A to h. Well, if we multiply all of these, 50 times 24 is 1,200. 100 times 12 is 1,200. 120 times 10 is 1,200. And 150 times 8 is also 1,200. So that means this is inverse variation, where your constant of variation is 1,200. So that is going to be our equation, but we want to make it relating A and H. So A is equal to 1,200 over H. Sorry, over H. So now we can use this equation to predict the height of a carton with the same volume as those in the table that has a base area of 75 square inches. So this is my A value. So 75 equals 1,200 over H. Well, we'll multiply both sides by H. And we get 75H equals 1,200. And what we're going to do next is divide both sides by 75. So 1,200 divided by 75, and we get 16. So H is equal to 16 inches. All right, so down here I wrote out the differences between direct and inverse variation, what the equations look like, how to get the constant of variation from a table or from a word problem, and then what words to look for in a word problem. So take a minute to copy this down. Hopefully this was a great introduction to inverse variations and to see the difference between inverse and direct variation. So thanks for watching. Make sure to like the video and subscribe.